Okay, these are the circle theorems that deal with angle, measure, and segment length. So we're going to talk about when you have secant lines or chords, which would go through the circle, they would intersect the circle in two places, and the intersection is inside the circle. Okay, so when we do that, we end up with this relationship where the measure of one of the angles for the intersection is going to be equal to 1/2 the two intercepted arcs. So it's going to be the sum of the intercepted arcs. So the measure of angle 1 is going to be equal to 1/2 x plus y. So we add the intercepted arcs as the sum of the intercepted arcs, and then we multiply by 1/2 or divide by 2. So we're looking at this one. That would be the measure of angle 1 is going to equal to 1/2 the sum of, and this would be KL plus MN. And if I was going to say, how about the measure of angle 4? Well, that would be equal to 1/2 the arc length of ML plus NK. Okay, so it's just the intercepted arcs, the sum of the intercepted arcs. So we use that one relationship to find this one. So we've got the measure angle, so we're going to say 35 degrees equals 1/2 of 30 plus x. Okay, well, if we continue that, we multiply by 2, and we'll say, okay, well, 70 equals 30 plus x. If we subtract 30, then x is going to equal 40 degrees. Okay, for this one, we have two arcs, and we're looking for the angle. So we're going to say x is going to equal 1/2 150 plus 140. Okay, so x equals 1/2 of 290. So x is going to equal 145. So this is 140 degrees. Okay, and that's how we find either the arc if we're missing one of the intercepted arcs, or the angle if we're missing one angle. And keep in mind, this is for secant or tangent lines, meaning they intersect the circle at two places, and their intersection of the two lines is also within the circle, inside the circle. Okay. The second part of this section deals with the chord lengths, okay, within the circle, and the relationship is the two segments M and M, so the product of the two segments equals the product of the other two segments. So M times N equals K times L. Okay, so we're going to take this particular one and we're going to do it. And actually, this right here is 3, and this one right here is 7. So I know it's a little bit hard to read. So we would say 6.5 times M is going to equal 3 times 7, which gives us 6.5 M equals 21. And then if we divide that out, we're going to get about 3.2. So it's not quite, it's about 3.2 to estimate. Okay, so we look here, we have this circle right here. We've got more information than we need, so it's important that we're able to weed out extra information. The first thing it asks for is, what is the value of x? Well, here's x. X is this segment length from here to here. This over here, this side of the segment is 10, and then the intersecting segment is 9 and 6. So for number 1, we would say that 10 times x is going to equal 9 times 6, which will give us 10x equals 54, and then x is going to equal 5.4. Okay? 2 asks us to find the value of y. And of course, that one is actually going to be the angle. So we're going to have to use the 1/2 sum. So I'm going to say angle y, or y, is going to be equal to 1/2 sum of the intercepted arcs, which is 85 plus 45. Okay, so, oops, not plus 4, plus 45. So we'll say plus 45. Good. And then from there, we can simplify. So that's 1/2 times 130. And then 1/2 of 130 is 65. So x is going to be equal to 5.4 units. That's the segment length. And y is going to be equal to 65 degrees. So practice problems for this section are numbers 15 and 16 from section 5.4. So we need to practice 15 and 16 from that section.